Hello everyone, and thank you for joining us for the third installment in our webcast series. In this session we will be discussing message-driven and web services with Spring and JAX. I am joined today by Pyongguk Cho, who is the Web Services Product Manager for WebLogic, and Dave Cabellas, who is the JMS or Messaging Product Manager for WebLogic. Pyong and Dave will be giving you presentation overviews of the features on WebLogic, and I will be walking you through the code. So before we get started, I wanted to talk a little bit about the support for Spring that WebLogic has. The Spring framework has proven to be popular among developers building applications in Java. And so for a number of years, WebLogic Server has supported the ability to develop and deploy Spring applications on WebLogic. In particular, we've provided a number of integration features that enable Spring apps to be hosted on WebLogic Server. We automatically simplify the process of configuring Spring with pre-configured beans such that Spring apps can more readily leverage the underlying capabilities of WebLogic. For example, we support the ability to leverage from Spring applications WebLogic data sources, the WebLogic JMS implementation, and also work managers and thread management within WebLogic. We enable Spring apps to take advantage of WebLogic clustering, the WebLogic JTA transaction service, and supported Spring applications through standard management tools such as the WebLogic console and WST. Also, through OPI, we provide the ability to build Spring apps in an Oracle-provided Eclipse-based IDE. So, WebLogic supports Spring, and by running Spring on WebLogic, you can take advantage of a lot of benefits that are offered with WebLogic, such as clustering and the high-performance JMS. So there's a lot of benefit to running Spring on WebLogic. So for this session, we wanted to provide an overview of Spring running on WebLogic and compare and contrast the Spring functionality with standard Java functionality. For example, we'll compare and contrast Spring Web Services with JAX Web Services, and we'll compare and contrast Spring MDPs with Java MDBs. So now I'll turn it over to Pyong.
In the next couple of slides, I would like to give you a quick introduction about WebLogic Web Services stack. We focus on three different areas. First, we offer the world-class implementations for JAX-WS API and for Web Services standards. Second, we make sure that all the features we provide in the stack will be reliable, scalable, and performant, so that it can meet the enterprise application requirements. Third, we heavily invested in interoperability assurance program so that customers can build applications that can interoperate with the other Oracle FusionMeter products as well as with third-party web services stacks. Here are some of the features I'd like to highlight. On the standard buckets, as I stated earlier, we provide implementations for the programming APIs as well as a number of web service standards such as web service policies, security policies, reliable messaging policies, etc. You can use MDB for binary data handling. You can create a transactional web services using web service atomic transaction. For interop assurance, web services stack from Oracle is compliant with web service interop profiles such as basic profile, basic security profile, and reliable secure profile. Not every aspect of web service application is covered by standard. For those areas, we provide our own solutions. For example, you can create database web services out of database resources such as tables and SQL statements. In addition to standard HTTP transport, you can create SOAP endpoints over JMS transport. You can choose to use different data bindings. If you need richer message exchange patterns, you can take advantage of asynchronous web services or stateful web services that are available in WebLogic Web Services stack. Customers demand end-to-end manageability for any enterprise applications. As such, we provide management and configuration management for web service applications. You can attach policies or make configuration changes after the application deployment. You can also have a visibility into each application in terms of their performance and the policy violation status. In summary, Oracle Web Services provides a number of building blocks for Web Services Java programming model and for qualitative services that can be enabled in a declarative way so that you can implement what we call enterprise web service design patterns, such as guaranteed delivery or long-running services or service virtualization, etc. Our goal is to make it possible to implement any of those design patterns without too much pain. In the next couple of slides, I'm going to explain how Spring Web Services works. Let me start by describing the philosophy and rationale behind the Spring Web Service design and architecture. Spring Web Service is very much document-driven, and it advocates contract first, meaning you can create Spring Web Services from existing WSDL file. At least you've got to start from the existing schema definitions. It has a very pessimistic view about the mapping between Java classes and the WSDL file, and hence it has a very loosely coupled architecture between the WSDL contract and business service implementation. For example, it doesn't perform the schema validation for the incoming SOAP messages by default. Not surprisingly, Spring Web Services inherit most of the key Spring concepts, such as dependency injection, and it makes use of application context, bin factory, etc. It is built on top of Spring MVC and very much POJOS-centric. For every aspect of a web service execution, it allows you to plug in third-party frameworks. For instance, for the XML parsing, you can use different XML APIs, such as JAX-P or JDOM or Axiom, etc. By default, it does not perform the XML marshalling. If you want to enable it, you will have to use one of the existing XML marshalling frameworks, such as JAX-B or Castor or XML Beans, and so on. Spring Web Services allows you to use different transport, such as JMS or HTTP. As far as WS security support, you can use SSH security framework for authentication. If you have existing applications, such as JAX-WS applications, you can easily convert it into Spring application using JAX-WS Commons library. Let's drill down to details on how to create your services in clients. On the service side, you will create an endpoint first. You can choose to use one of the existing abstract class that provides most of the plumbing works for you. Or you can use endpoint annotation directly and create a endpoint class from the scratch. You can specify the marshalling types and other parameters. And again, it is very much XML-centric. You will be dealing with XML payload directly, and the endpoint itself will be POJOS. Once you have endpoints classes, then you can define the endpoint mapping, which specifies how the incoming SOAP messages will be routed. You specify the URL, and it can be done for the SOAP action, HTTP header, etc. On the client side, you will be using Web Service template, which is very similar to Spring JDB's template. Just like services side, it is very loosely coupled, meaning that the client runtime does not make use of information on the WSDL file. Again, you will be dealing with XML, meaning SOAP messages directly. You can use Web Service message callback, which is very similar to JAX RPC or JAX-WS handlers, if you are familiar with it. It allows you to set SOAP headers or inject transport level properties. You can use different HTTP clients, such as Jakarta Commons HTTP client, if you need a special qualitative services.
In our first session, we created the OPS domain project, which was the JPA library for data access. We ran that standalone and didn't package it in an application. But for our applications that we're deploying, so the web services, the JMS services, and the REST services, we chose to create a set of EJBs to serve as data access services. So here we have a parcel manager and a shipment manager. So we have one manager for each of our entities, each of our main entities. And we have methods that we can use to interact with the data access layer using our domain objects. So let's take a look at the implementation of the shipment manager. The shipment manager is a stateless session bean, and one of the benefits of using an EJB or EJBs for doing the data access using JPA is you can inject the persistence context entity manager automatically in the container. So we don't have to worry about the entity manager factory or any transaction settings. All that's taken care of using the container. So let's take a quick look at this create shipment method. Here I'm sending in a shipment and then I'm persisting it. And for each of the parcels on this shipment, I am setting some values, mainly billing information received for each package. And then I am persisting it. So now let's take a look at the business services that we have created, also an EJB project. Here I have a parcel service and a shipment service, and these actually use an XML interface. So these are my JAX-B request and response objects that I'll expose using JAX-WS and Spring Web Services. So if we look here at one of these methods, we'll see again this is a local, it's got a local interface, stateless session bean, and here I accept a request, then I take an action with my entity manager, and then I create a response to send back to the caller. Next, let's take a look at the Spring Web Services project. Get started by looking at the web XML. Here I have my two EJB references, so I can use those in this application. Standard Spring configuration, and then I have defined two servlets, one for each of parcel and shipment services. Next, let's take a look at the shipment servlet XML. So for each of my servlets, there is a servlet application context being configuration file for Spring. So in this case, my servlet is named shipment, and so there is a shipment-servlet XML file that holds the configuration for that service. I'm using annotation-driven Spring Web Services, so I have to have this configuration, so it will pick up the annotations. Then I import my application context, which has my EJB references. And then I define my endpoint. So let's take a look at this. So here I'm using the Spring Web Services endpoint annotation. I'm auto-wiring in my shipment service. And then for each operation, I have to have my payload route mapping, my request payload, and response payload annotations. The payload route defines the local part and namespace of the request that's coming in, and then this defines the request payload that's coming into the method, and then the response payload indicates that there's something coming back. If you use different variations of including the response payload but not the request payload, you may get error messages like no appropriate handler found, which can be kind of frustrating because I had the request payload annotated without the response payload, so the request would come in and be processed, and then when it was going to return the response, I would get an error message saying no handler found. So it was a little bit misleading and kind of troublesome to get working. So for each one of my requests, I proxy it to the shipment service, and this is my EJB, and then I just return the response there. So what this allows is the business logic is here in the shipment service, and then in the case of doing advanced error handling, so SOAP messages or SOAP fault responses or where to send exceptions for this interface, that can be handled here in the interface. So let's go back to the servlet configuration. Here, as we've seen in my endpoint, I'm using the payload route annotation method endpoint mapping that will map the requests that are coming in via SOAP to that endpoint. So I have the default endpoint to shipment, and then I have a payload logging interceptor that simply prints out the payload of the message to the console when the request is received. I'm using JAX-B classes, so to do the marshalling, so I am declaring a JAX-B marshaller and then using it for my generic marshalling method endpoint adapter. Finally, I have my dynamic WSDL definition bean capability here, where I define my port type name, specify the schema collection that's used for my WSDL, and then the location URI. When you look at the schema collection, it's important to inline the schemas that you include, assuming there's multiple schemas, such that when you export your WSDL, it can be standalone, completely standalone. So here I'm importing my shipment service, shipping, and common XSDs. Let's take a quick look at those. So here I have the schema definitions for my create shipment request and create shipment response objects. You'll notice here that there's a request header and a response header, which is just good practice to have on your methods, your web service methods. And what this gets us is, for this example, I have a source system, and this is a request header. I've got a source system user, and a source system transaction ID. Then on the response header, I have a place to include the request header, the local transaction ID, whether or not the request was successful, and then a user-friendly message for the status of the request. So if you pass in a transaction ID from a source system and then include it in the response, it becomes easier to map the request and response to specific transactions. And it also becomes easier to use something like AmberPoint to track your exceptions and the flow of your messages through the system. So I've got one of these for my shipment servlet and one for my parcel servlet, because those are the two services that I'm using. Next, Pyong will give us an overview of JAX-WS, and then we will compare and contrast that with Spring.WS.
In the next two slides, I would like to introduce JAX-WS programming model to those who are not familiar with it yet. JAX-WS stands for Java API for XML Web Services. It is the second generation Web Service API following JAX-RPC. There is no major difference in terms of programming model between them. You can create JAX-WS applications from a given WSDL file or from your Java classes. We call it a top-down development scenario when you start from a WSDL file, whereas in the bottom-up scenario, you will start from your Java classes. Either way, once you deploy your JAX-WS applications to WebLogic, you will have service endpoints up and running, and as a part of it, you will have a WSDL file URL. You can use the WSDL file to generate a client proxy. Client proxy is a class that allows you to invoke your target service. It also includes a number of JAX-B classes that are used to marshal and unmarshal your SOAP messages. The JAX-WS runtime environment on the client side as well as on the server side will take care of all the mappings and the protocol handlings so that to the application developers, everything is smooth. Oracle provides a number of choices for JAX-WS development tooling support. You can choose to use WebLogic Web Service End commands such as JWSC or WizardC to develop JAX-WS applications. JDeveloper allows you to develop JAX-WS applications and SOAP applications. It also offers a very user-friendly WSDL editor so that you can create a WSDL file easily from the scratch. There is a web service testing tool called HTTP Analyzer as a part of JDeveloper, which is very handy when you just want to test your web service endpoints without having to create client applications. You can also create database web services out of tables, SQL statements, or PL/SQL packages. It's also possible to create JAX-WS applications using JDeveloper. OP stands for Oracle Enterprise Pack for Eclipse. If you are an Eclipse user, you can download and install OP plugins. Using OP, you can create JAX-WS applications that can be deployed to WebLogic directly. OP also has a Visual Wizard editor that can help you to author a brand new wizard file. Sometimes you may want to override default mapping rules for JAX-WS or JAX-B, and OP offers a custom binding file editor that can help you with that. What you see on the right-hand side is a property inspector that allows you to override WebCV annotation properties, and this is the wizard file editor available on OP.
Now we'll take a look at the JAX web services. So you'll notice here I have a web XML that has my EJB references, and then I have an endpoint for my parcel web service and shipment web service. For my shipment web service, I have the web service annotation where I provide the name, service name, and target namespace for this operation. I have my shipment service here, in the shipment service EJB injected by the container, and then for each of my methods I have the web method annotation, and these are the only annotations that you need. Obviously if you weren't using EJBs you wouldn't need this one, but for your endpoint you have your web service and your web method definitions, and that's pretty much it. So it's pretty easy to create a web service using JAX-WS. One difference is that you have to use the WSGen functionality of JAX-WS to generate the request and response object mappings that will be used by the web service. So let's take a look at how we would do that with Maven. So all of the projects are in the OPS application are wired using Maven. So you don't have to use Maven to run WSGen, but we provide this for you pre-configured so that you can use it. So if we take a look at the OPS JAX-WS project, let's take a look at the POM file for that. Here we'll see that I have a profile defined for generating my parcel service and generating my shipment service. I'm using the JAX-WS Maven plugin and specifying the WSGen goal. Here I'm specifying the shipment web service as the service endpoint interface, and I'm keeping the source files in WSDL that are generated. Here I'm specifying the directory where I want the source files that are generated for JAX-WS to be created. Then, if I want, I can execute this by enabling the profile for generate WS shipment. So now when I run the install goal, here's the Maven output. We'll see that JAX-WS is running, it's generating my classes in there. So let's go back and look. So here we see the WSGen starting, and it's looking at my shipment requests, generating the objects for my method. And there we go. So that's how you would execute it from an IDE using Maven. Of course, we don't have to actually execute this from the IDE. We can also do it from the command line. So I have my Maven clean install, and I'm activating my generate WS parcel profile, which will enable the WSGen. So there it goes, doing the WSGen. Now it's building the WAR file, and now it's complete.
So before we dive into Spring message from POJOS on WebLogic, I thought we should talk about some of the details of the messaging engine that we'll be using in the demo. So we're going to use WebLogic JMS, which is a full-featured high-performance messaging engine that comes with WebLogic Server. So one of the key factors of its value is it's built into WebLogic servers. So why is that good? So think about, you've got nothing else to install, nothing else to manage. It's not a separate process. It uses all the same tools for managing and configuration and monitoring. It also uses the same security configuration, again through the same set of tooling. And then, of course, there are some performance benefits of being built in here too. There's no need for network hops, right? You're going to send and receive right from the same JVM process. There's no need to serialize, deserialize as you go out over the wire and come back. So all that is, just generally good from being built in. And besides that, the messaging engine itself is, of course, spec compliant. We support JMS 1.1 and 102B. Besides that, of course, we have a number of extensions. To start with, thinking about a micro level here, we've got things like timed messages, so you can set message availability time or born on time, right? To say, okay, I don't want this message to be available until a particular time. And then you can also set things like time to live, expiration time for a message, that after a given amount of time, just expire it and make it go away. Thinking in terms of micro type extensions, we've got extensive error handling for problem or poison messaging. So we've got error destinations that you can set up. We've got a number of retries and so forth. So thinking in terms of a macro perspective or an administrative perspective, WebLogic JMS has a full set of HA capabilities, including clustering for location transparency. So you can set up a cluster, set up a JMS server on servers in that cluster, deploy distributed topics or distributed queues to those JMS servers, and then those distributed queues and topics look like individual queues from a consumer or a producer's perspective. Clustering also provides load balancing and failover, so messages get load balanced across. And we've got various different performance optimizations built into that load balancing as well. Specifically server affinity, where if you're connected to a given server and you're going to send a message and you've got a consumer set up ready to receive that message, why bounce it around the cluster? So besides HA, we also have some unique ordering capabilities or features built into WebLogic JMS. So continuing with our WebLogic JMS overview, I wanted to talk about a few features and capabilities that we have that appeal to not only to administrators and operators and architects, but also to developers. So first on the list here is broad message management capabilities. So built into WebLogic is the ability to look at messages that are in a particular queue. You can look at the headers, you can look at message bodies, you can move messages, delete messages. You can also pause the destination or groups of destinations for consumption or for production. And all of this tooling is available through the admin console. It's available through MBeans. It's available through WebLogic scripting tool. So no matter how you want to work with these capabilities, they're really available to you. Then besides that, we have lifecycle logging. So again, from a developer perspective, this is something you can use to kind of track and see where messages are going, where they're getting hung up. So when you turn on lifecycle logging, for every stop in a message, in the processing of a message, we log a record. So for example, when a message is actually received in a queue, there's a message log there. When it's then received by a message receiver like an MDB, we log it. If there's a rollback or an acknowledgement, all of that gets logged as well. So that's the idea here is full visibility, so you can troubleshoot whatever could be going wrong with your system. From a performance perspective, we've got a number of different features or capabilities that are of interest to developers also. So we've got logging last resource, which is a transactionally safe last resource optimization. When I say transactionally safe, it means we can fully recover that. So if you need to do a rollback or the system fails during the processing, we can actually fully recover that. So you end up with a consistent data state. We've got one-way sends that don't require any acknowledgement at all. We pipeline messages to receivers. That is, we want to keep the receivers as busy as possible. So when they do a receive, we'll send a group of messages instead of individual messages. Of course, that's tunable. We've also got this capability called MDB transaction batching. That's depicted in the diagram on the right here. The idea here is that MDB, when a transaction starts, we get a message. we complete that transaction but we don't commit, then we go back and we see, is there another message for this MDB? And if there is, and we've got room in this transaction batch, then we add that message to the same transaction, and then we keep doing that until we fill up the transaction batch level, or until there are no more messages available for this MDB to consume, and then we commit that group of transactions as a single transaction. So we amortize the overhead of transaction processing across however many you decide should be in your transaction batch. We've seen really great performance boosts here, up to like 5 times the performance of a single transaction, and in some cases that means transaction performance is faster than non-transactional scenarios, because we're able to batch all that. There's also a database implication too, so all of those transactions end up being linked together and optimized on the database side as well. We also have again, performance optimizations and ease of use optimizations aimed at developers here for EJBs and servlets that produce messages. So if you use a resource reference either in an annotation or in a deployment descriptor, we turn on this wrapping capability that's built in. There's nothing else you need to do, and when that's turned on, we automatically pull JMS resources, as in sessions and producer objects. So when you close those objects in your application, they actually get cached instead of closed. This is again a performance and an ease of use benefit, and then the same thing for transactions. So if you're producing messages as part of a transaction and you've turned on this resource reference wrapping, then we'll automatically enlist JMS resources as part of that transaction. From a receiving side, it's using an MDB container. The MDB container actually does all this things for you without having to do any resource referencing at all. The last on the list here is foreign JMS servers and destinations. Primarily, this is a feature that enables you to use other JMS implementations other than the JMS implementation that's built into WebLogic server. So this makes it really easy for you to use. You set up a foreign JMS broker or server and the foreign JMS destinations so that they appear as local JNDI objects. Then your applications can just use them as if they're local. Under the covers, we take care of the connections and so forth. And we'll bring this up again later. There's a nice little workaround that applies to Spring.
Before you take a look at the event handler code, I wanted to give you an overview of the JMS architecture that we have for our event handling system. So we have messages coming in to an event queue, and there is a listener that listens to this queue and forwards the message on to the event topic. The reason that we have this is that messages coming into the system, we don't know if they have the appropriate header values that we're expecting, such that we can handle and filter events appropriately. So what the queue listener does is it adds the appropriate header values, in this instance, for this example, partial status, and then forwards it on to the event topic. And the goal here is to enable event handlers to be able to filter for specific message types. So you see the top event handler is filtering for partial status equals delivered. So when this particular message gets delivered, it will go to all of the event handlers except the one that is filtering for partial status equals delivered. So the goal of having the event queue and event topic is to make sure that we have the appropriate JMS headers on the messages that are delivered onto the event topic. So now let's take a look at the Spring message-driven services that we have. So as we discussed in the architecture overview, there is a queue listener that takes messages and forwards them onto the topic. So let's take a look at that first. Here I have my event forwarder message listener, which is an MDP that implements message listener. There's an onMessage method for message listener, and then I'm looking for text messages and forwarding those onto the topic. So let's take a look at how that's done. Here I'm unmarshalling the event, or the message, into my event, doing standard JMS lookup and binding. Then I'm creating a new text message, proxying the properties from the first message onto the new message, and then I'm setting the properties that are relevant to the domain object. So I'm setting the parcel status, which I'll be filtering for on one of my event handlers. I'm also setting some other things that I'm not filtering for, just for reference. So this is the actual implementation file. It looks pretty much like an MDB, or how you would do a message listener using standard Java. The difference is the difference is the event queue application context that I'm specifying here. So here I'm importing my JMS application context, where I have a JNDI template that I use for my JMS destination resolver and my JMS connection factory lookup. Then I'm using the default message listener container, and I am using my event message listener reference that I create here, where I'm specifying my forwarder to use this connection factory and forward on to the topic. Then I'm providing the connection factory, the destination resolver, and the destination name. So since this is listening to the queue, I'm specifying the queue destination here. Now let's look at the Spring MDPs that we have for the topic event listeners. So we'll take a quick look at the WebXML. The key point here is to see the EJB local reference. I'm packaging up the WAR file for the Spring Web Services and Spring MDPs into an EAR file, where I have an EJB jar that contains my entity managers for parcel and shipment. And here I'm specifying the local JNDI reference for those beans. Now let's take a look at the event topic application context. Here I'm importing an application-EJB file where I have references for my parcel manager and shipment manager EJBs. You'll notice that if I don't set resource ref to true, I have to provide the Java conf env prefix in order to get the full name, JNDI name, for my entity manager beans. So now let's take a look at the event topic listener container. This is an abstract bean where I'm specifying common properties that are shared amongst all of my event handlers. You'll notice here that I'm using a foreign JMS prefix on my destination name. I've configured a separate foreign JMS server for each of the nodes in my cluster and targeted them to the single node in the cluster that they correspond to. If I was not using foreign JMS, I would have to specify the name of the member destination, which includes the JMS server name as a prefix to the distributed topic JNDI name. I have a 2-node cluster, and therefore I've configured 2 foreign JMS servers and corresponding foreign destinations for each of the nodes in the cluster to take care of this mapping. Otherwise, I might have had to create separate archives for each node in the cluster and target them separately to those nodes. For more information about this, check out our YouTube channel, where we will be posting a more detailed overview of how to set this up. You'll notice that I'm passing in a managed server name, which you can get from the environment property WebLogic.name, and I'm using this to construct a unique client ID and a unique durable subscription ID for each event handler. So before we go any further, let's take a look at this class, the Event Topic Listener container. It's a very simple class, and all it has is a reference for an event handler. When I construct this class, after the properties are set for the bean, I'm constructing an Event Message Listener MDP, storing it locally, and then setting the event handler on the MDP. So let's take a look at the MDP. This is a very simple class implementing the message listener interface, and therefore has an onMessage method that is called when it receives a JMS message. Here I am printing out the JMS headers. Then I'm unmarshalling my text message, the XML in the text message, into my domain event, and then I'm passing the event on to the event handler reference that I have. Let's take a quick look at this. For the abstract event handler class, you can find all the event handler classes in the OPS Event Handlers project. For the abstract event handler class, this has references for my parcel manager and my shipment manager. And then the concrete classes simply have a handle event method where they take a parcel log event and then take an action. For these event handlers, I'm simply using the parcel manager or shipment manager to proxy the event or proxy the information on to the domain layer data access. So let's look at the abstract durable topic listen container class. This is the parent class, abstract class for handling durable subscriptions on a topic. You'll see that in the after property set, for my container, I am specifying the subscription to be durable. I'm specifying it also to be on a topic. Here's where I'm constructing my unique durable subscription name and client ID and then setting those on the container. And then I'm also setting the message selector if one is supplied. So I have a event topic listener container bean definition for each one of the event handlers that I want to use. You'll see that I'm passing in a property name for the event handler, again for the client ID and durable subscription ID. And then I'm passing in an event handler that is specific for each event that I want to handle. So for this example, this bean is the parcel log update listener, and so the event handler will update the parcel log with the event that comes in. And here I'm wiring in my parcel manager and shipment manager entity manager references. You'll notice that on the package delivery notification event listener, I'm specifying a message selector for parcel status equal to deliver. For the case of adding another event handler, you would have to make a descriptor change here. And this would be regardless of how I've constructed the event handlers here, which is fairly abstracted and would make it easy to make these change. Nonetheless, you still have to make a descriptor change for every new MDB that you would have to, MDP that you would want listening to your topic, and specifying the different parameters for that.
So although WebLogic Server is pretty flexible in supporting Spring message-driven POJOS, there are some limitations that you should be aware of. The main concern for MDPs is that they're not cluster aware. In other words, all of that topology handling that I mentioned earlier with regard to the MDB container and handling of subscriptions for partition distributed topics, well, MDPs don't handle that, right? So for a simple case with a local non-durable subscription, MDPs work fine. If you add a durable subscription, things get a little bit more challenging. Remember that you can't create a durable subscription directly on a distributed topic. The WebLogic MDB container does that interpretation for you, so you can do it through an MDB, but non-MDB subscribers really don't handle that. So in that case, you can actually use a JNDI mapping capability in foreign JMS configuration in WebLogic Server to map a consistent common local JNDI name for the distributed topic, and you map that to the local topic member name, the actual local the JNDI name of that local member topic, not of the whole distributed topic. So hopefully that makes sense, right? You're going to give a common name, so your MDP will use that across the cluster when you deploy your MDP across the cluster. For example, you would say map com.oracle.event topic as a local JNDI name, and then you would map that to the JNDI name of the distributed topic member, such as JMS-server-1 at distributed topic JNDI name, right? So it's, that's kind of how things fall out in that case, and you would then apply that mapping differently on each server in the cluster, and then use that map name in your MDP application context.xml descriptor entry for the JNDI name for that topic, right? And so that would enable you to deploy this MDP across the cluster, and then locally the JNDI name that you've defined in the application context.xml would resolve appropriately on each server. Hopefully that makes sense. It's a little complicated in words, but that's the idea. So it's important to note that even with this mapping, if you take advantage of JMS service migration for high availability, this won't work. One other thing to note too is that for the remote case, where MDPs are deployed on servers that are remote from the servers that host the distributed topic, there is no automatic handling for clustered subscriptions as there is for MDBs. So if the topology changes for any reason, either expansion or failure, you either add to the cluster or one of the servers goes down, the MDB won't automatically react. And then besides the cluster limitation, there are some other things to watch out for. So WebLogic JMS uses a thread-based security model, and Spring assumes an object-based security model. So that mismatch can be tough to work around. The simplest option really is to keep everything behind a firewall and use that firewall as your security. And one last item on the producer side, WebLogic provides automatic JMS session connection and producer pooling for EJBs and servlets, but Spring doesn't provide that optimization. So it's we don't see it so much on the listener side, but on the producer side, it's something else to consider. So on the other hand, WebLogic message-driven beans have some distinct benefits over message-driven POJOS. For example, you can use the message-driven annotations right in the class file to define message-driven properties in a listener. There's no need to wire things together in a separate descriptor file. Also, the MDB container handles the details of subscriptions and message handling with direct knowledge of the WebLogic isms of WebLogic, right? So it spins up MDB pools where it's appropriate. It handles subscriptions automatically for both local and remote cases. It adapts to topology changes for both local and remote cases. So, for example, if you have failover or you expand a cluster, the MDB container really handles all of that. MDBs also have the same security model as WebLogic JMS, so there are no challenges there. And then MDBs automatically pool JMS resources for the receive side, and for the send side, WebLogic JMS also pools JMS resources for EJBs and servlets using a wrapper technology. So just a side note, MDBs are the most commonly used form of message listener. So why is that good? Why is that important? It really means that they get the most attention, they're the most heavily tested. There's the most material on most information on how to use message-driven beans. So that is really what we recommend. I did want to point out some details on the message-driven annotations available on WebLogic Server, especially with regard to some annotations that enable you to fine-tune message handling for distributed topics. Connection factory JNDI name, destination type, and subscription durability are all pretty logical entries, so I'm not going to go into those. But topic messages distribution mode and distributed destination connection are a bit different. So let's start with the first one, topic messages distribution mode. This annotation tells the MDB container how your MDB expects to handle messages, or how your application expects to handle messages. So options for the annotation are 1 copy per application, or 1 copy per server, or compatibility. So 1 copy per application, this is the most common use case. It tells the MDB container that you expect messages to be load balanced and processed in parallel. That is, you want only 1 copy of the message to go to each of the MDB types, no matter how many pools of instances of the MDB type there are. So for example, if you've deployed your MDB application across a cluster, you only want one of those cluster members to get the message. For a partition distributed topic, the new style topics that we added in WebLogic Server 10.3.4, the MDB container will create a subscription on each of the partition distributed topic members, and then depending if you're local or remote, it'll do the right thing. And that's pretty straightforward. For the replicated distributed topic, which is our old style, where we forward messages between the different members, with this 1 copy per application annotation, the MDB subscription actually ignores any messages that are forwarded. So you still get the same behavior whether you've got a partition distributed topic or a replicated distributed topic. I know it's a little complicated, but just think that the MDB container will do the right thing. If you tell it 1 copy per application, it's gonna get what you want. 1 copy per server enables you to get that replicated scenario, kind of even if you don't use a replicated distributed topic. So even with the new topic, the new distributed topic behavior of not forwarding messages, the MDB container will actually subscribe as needed across a cluster. And that's the last one of these options for topic messages distribution mode is compatibility, and that's really used for backwards compatibility. That's the default, and we use that because we want to people to be able to migrate their applications from previous releases to the new release without any failures. So we keep that as the default, but really the idea here is to use one of the other options. The other annotation is distributed destination connection. That tells the MDB container where you want to listen for messages in a distributed topic. It's used for local deployments only, and it's ignored for remote deployments. The two options there are local only, which is the default, and that's where the MDB container will create subscriptions on a local distributed topic member only. The other option is every member, which means the MDB container will create a subscription on each of the different members, and it will enable each of the MDB pools to subscribe across the cluster. One reason for that is really to be able to let you to load balance at another level, right? So we can load balance messages as they come in, but if you've got a slow server or a slow set of consumers on one server, you can end up with a backup on one particular server, and if you use the every member option, it'll kind of level all that out for you. The doc URLs listed here on this page have a lot more information here, so I've covered kind of the high level of this, but there's a lot of fine-tuning that can happen, a lot of different scenarios that you can use with these different settings, and the documentation really it has a diagram and the different settings you need to do to kind of get a bunch of different scenarios to work out. So just to recap a little bit, the Spring MDPs that we talked about earlier are pretty simple to use on WebLogic Server, and Jeff has demonstrated that for us. But message-driven beans are even easier, and they have more intimate knowledge of WebLogic isms in WebLogic, especially with regard to clustering and distributed topics. So Jeff is going to walk us through an example of an MDB right now.
I just wanted to let you guys know that we have 50 minutes of content here, so we have a full session. If you have questions that you want to ask and get answered, please go ahead and use the functionality in the web conference tool to submit those so we can prioritize them and get them answered as quickly as possible. So let's take a look at the Java MDBs that we have. You can find them in the OPS JAX JMS project underneath the OPS Services JAX project. First, we'll look at the event queue forwarder. So this is the MDB that is listening to the queue where events come in. It is then taking the events off of the queue, creating a new message and setting JMS properties for that message relevant to the domain object, and then forwarding the message onto the event topic. There are a few differences between an MDB and an MDP. First, you'll see that we're using a message-driven annotation here, and we are setting relevant properties for the MDB on the class itself. In the case of an MDP, you have to define the message listener and the message listener container in a deployment descriptor. And in this case, since we're using EJBs to do the entity access for the entity managers, you also have to include a web XML that it has the EJB reference names so that you can look them up when you create the application context for Spring. So in this case, for this class, we are doing the same code that we would in the Spring, or that we do in the Spring version, where we forward the event message using the same method on the same class. So now let's take a look at the MDBs that we have configured for listening to the topic. For starters, we have an abstract event message listener that implements the message listener interface. Most of the logic for the event handler listener is included in this class. Here we have our parcel manager and shipment manager provided via EJB injection, and we also have an event handler reference that is set in the implementing class, the concrete class, that extends the abstract event message listener. So here you'll see that we have an onMessage method for the message listener. I'm printing out the header information of the messages, of each message. Looking for a text message, I first unmarshal the event and then pass it to my event handler. The event handler is constructed and set in the implementing class. So here we'll take a look at the add parcel log message listener. Here in the default constructor, I set my event handler to take the action of updating the parcel log. And this is the same class that we have for the MDP code. The major difference here is, again, we are using the message-driven annotation to create an MDB. Here, like on the queue, I set my MDB name and the JNDI name of the destination that I'm listening to, and here it's the topic. My connection factory, set the topic as the destination type. And then the next three properties I have for the subscription durability. I'm enabling a durable subscription. And then, as Dave discussed, we have the topic message distribution mode to be 1 copy per application, which will deliver the message to all of the MDBs within that application on one single node. And then I have the distributed destination connection specifying to listen to my local member only. So when you have MDBs that are deployed to the same container as the destination, you would use a local subscription, versus if you have MDBs deployed on one app server and the destination on another, then you might change this to be something other than local only. So in this case, all of our message-driven beans are configured using the message-driven annotation, and there's no deployment descriptors necessary. So it's pretty straightforward, pretty easy to configure, and all of the work is done in the class, and you don't have to have additional deployment descriptors in order to set up simple message-driven services. So we'll start processing questions now, and in the meantime, if you can give us some feedback about how we're doing, we'd really appreciate it. We want to know if this is valuable, if you want to see more things like this from us, or if there's a way that we can change it to make it more valuable for you. Please let us know so we can make these programs better for you in the future. Thanks.